Welcome to section 5.6 of college algebra. My name is Gregory Carlson, and let's wrap up this chapter with graphing systems of linear inequalities. So we've graphed and we've solved and graphed linear equations, even 3 by 3 linear equations, and nonlinear equations in the last section. And so now we're going to solve inequalities. And you can tell it's an inequality because we have a less than or a greater than sign. So I'm hoping you have seen this before, but I'll go through it step by step just in case. As you know, a line represents a whole bunch of points that satisfy an equation. When we have a greater than or a less than symbol, that means we're going to be shading on one side of the line because we're going to have a lot more solutions that are shaded above or below that line. So the way to do this is to remember the big important rule. And the big important rule is something you should memorize. And the big important rule says, if you multiply or divide a linear any inequality, actually, an inequality by a negative number, you must flip the sign of the inequality. So, big important rule that you should memorize: if you multiply or divide an inequality by a negative number, you must flip the sign of the inequality. All right, so we'll keep that in mind as we do this. So let's graph the first one. X plus negative 4y is less than or equal to 9. What we should do is solve this for y, and then we will be able to graph it. So the first thing to do is to move the x over by subtracting it. When we do that, the x cancels with the negative x, which gives me, I'm going to write it up here, negative 4y is less than or equal to, and I like to put the x first, so that would be negative x plus 9. So what I did there was I moved the x over. Don't combine these because they're not like terms. Negative 4y is less than or equal to negative x plus 9. Now what I'm going to do is I'm going to divide by negative 4 to get y by itself. And that means we need to divide all of this by negative 4. And so those cancel, and we get y. Uh-oh, do you notice this triggers our big important rule? We divided by a negative, so we need to flip the direction of the inequality sign. So now it's y is greater than or equal to. Let's break this up. Negative x over negative 4 would become positive x over 4 plus 9 over negative 4. Well, that would actually be negative, so it'd be negative 9 over 4. Or you could put a minus right there. So now that we have this equation, we're ready to graph it. So y is greater than or equal to x over 4 plus negative 9 over 4. Well, negative 9 over 4, that's our y-intercept. That's about 2.25. So our y-intercept is going to be about right there at negative 2.25. From there, the slope is up 1 over 4. So up 1 over 4. Oops, there it is. Up 1 over 4, and so on. So there's our line. Now notice we have the equality here, so the line itself is part of our answer. So it's a solid line and a solid line. Okay, so that's part of it. Now, if you're doing your homework and it asks for a specific point, try looking at this and seeing if there's a value you can plug in for x that'll simplify to a whole number. Like, for example, do you notice if you plug in a 1 here, you get 1 over 4? 1 over 4 plus negative 9 over 4 would be negative 8 over 4, which is negative 2. So that means the point 1, negative 2 is actually on our line right there. Okay, that's that point. So just try to think of a clever value for x that'll make this resolve to a number. A little bit of trial and error there sometimes. However, this is only part of the solution set. It's y is greater than or equal to the line. So here's my way of doing this and what I recommend. Put your pencil on the line. If y is greater than, you shade up. If y is less than, you shade below. So in this case, y is greater than, so we're greater than the line. So all of our answers are up here, and including the line. And that's how you do it. There is another way of doing it, and that is you pick a point somewhere and you test that point in your graph. And if you get something that's true, like 10 is greater than 5, then that means that's an answer, and so you shade the side of the graph that that's the answer on, that is with that point. However, if you pick a point and it's not true, like you get something like 5 is greater than 10, which is not true, then you know that that's not a point, and so you shade on the other side of the line. Okay, so every point we check up here should satisfy this, and every point down here should not satisfy this. However, I think it's easier to just shade above or below. Let's do one more. Let's do this system right here. And I see that we have two lines we're going to graph. So let's do the first one. And I'm going to write it here. X minus 3y is greater than 7. Once again, we want to get y by itself. So minus x, negative 3y is greater than negative x plus 7. And now divide by negative 3. And once again, we've activated our big important rule. So we need to flip the sign. Y is greater than. Two negatives will make a positive. And positive over a negative is a negative. So there's line number 1. Let's go ahead and graph this because there is going to be a trick to this since we are doing two of them. So I have x over 3 minus 7 over 3. So the intercept, let's see, 7 divided by 3. So that's negative 2.333, which will be about right here. And then it's up 1 over 3. Up 1 over 3. Up 1 over 3. Like that. Let's connect those dots. Oops, and I've made a mistake. And hopefully you can see what my mistake is. Do you see how we are missing the equal sign here? That means that the line itself is not part of the solution set. So what we do is we make this a dotted line, and I know it will be hard to see this, but we make it a dotted line to represent the fact that the line itself is not actually part of the solution set. So that's a common thing to miss. As you can see, I just missed it. So always graph the line, but before you graph, make sure you see if the line should be solid or dotted based on if the equal sign is present or not present. Okay, next thing I notice is y is less than, so that means we're going to shade below. But you shouldn't shade yet because we still need to do the other line. So here's what I recommend you do. Grab your pencil and just do some down arrows, kind of tiny, all along the line. And that reminds us that in the end, we're going to be shading below that line. Okay, now let's do the other one, which is 6x plus y is greater than 7. And let's solve this for y. That's just one step. Minus 6x minus 6x. Y is greater than negative 6x plus 7. There's line number 2. Remember, I don't flip the sign here because subtraction does not cause the sign to flip. It's only when you multiply or divide by a negative that the sign flips. Let's graph the line. Our intercept is 7. 1, 2, 3, 4, 5, 6, 7. And it's going to be down 6 over 1. So negative slope, 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And this time I'm going to remember it's a dotted line for this one as well. So here's the dotted line. The line is not part of the answers, only the shading. Okay, now let's figure out where we need to shade. It says here that y is bigger than the line in our final y-intercept. So y is bigger, so that means we're going to shade above this line. It's a little tricky because the line is steep, but we're going to shade above this line. Okay, so now the question is, which region do we shade? Do we shade region 1, 2, 3, or 4? Because we need to shade one of them. Well, we need to shade wherever the two answer sets overlap, because that means it's an answer for both equations. So based on my arrows, can you see where they overlap? Is it 1, 2, 3, or 4? And the answer is region 4. We're down below this line, but above this one. And so here is where you would shade. All the answers are down here. On line regions 1 and 3, region 1 satisfies this one, but not this one. And region 3 satisfies the top one, but not the bottom one. Region 2 satisfies neither of them. And it's only region 4 that satisfies both of them. In other words, any points down here in region 4, and I just made these numbers up, don't read too much into those numbers. Only the points down here satisfy both equations. And that's how you solve a system of two linear systems. Be careful to make sure if they're solid or dotted. I use these little arrows on each one to help me determine where to shade. I will see you in part 2, and we will do a few more examples. See you there.